Um, I just looked at my phone right before I sent you, and somebody had sent me a message saying, are we having a session tonight? I hope that was you. Was that you?
No, it was not me.
Ugh. I mean, somebody else was expecting a session tonight, and I don't know how to find out who it was. Huh. That's weird. Hope I didn't get my signals crossed. Okay, well, what do you got tonight?
Did you get my emails?
Yeah, I did. I'm sorry. I got distracted here. More of the same?
Yep, pretty much.
Is this what we want to start right here?
Yeah, number one.
Okay. Hold on. Let me get that open. Let me get that closed. We're multiple choice now at least. Oh, we were yesterday. That's right. All right. Multiple choice is always a little tricky because we don't know what we're trying to turn this into. Now, you see how this problem would actually be easier if they picked the answer, put it on the other side, and said verify that identity. Because they didn't do it, it could be this one, this one, this one, or this one, which means we have to try to prove that it isn't one of these. And who knows how to do that? Well, so these are tough. What's the bottom turn into? This tangent plus cotangent is something we've seen before. That's the same as tangent plus 1 over tangent. So what does that become?
Tangent squared.
Tangent squared plus 1. In other words, if you add those two fractions, find a common denominator. What's the common denominator?
Tangent squared.
No, just tangent. And we end up with tangent squared plus 1 over tangent. So we get tangent squared plus 1 over tangent in the denominator. That's what tan x plus cotan x turns into. And the only reason I want to do that is because that I can replace with cosecant squared, which we happen to have in the numerator. So let's replace that with with secant squared. So much for my idea. So let's see, we have secant squared which is well, let's see. I guess we could turn everything into sines and cosines and see what we get. We get 1 over sine divided by 1 over, well, let's see, sine, the tangent is sine over cosine. Hold on a moment, let's see, 1 over cosine squared times tangent, which is sine over cosine, which is cosine over sine. See how I did all that?
Yeah.
Okay. Sines cancel because they're both in the denominators. And I end up with 1 over cosine in the denominator, which becomes cosine in the numerator. D. I guess the secret that I use, as I just now am discovering, is turn everything into sines and cosines and see if you can find the answer. At least as if you see some sines and cosines in these 4 answers, that's not a bad way to go.
Yeah.
Let's try another one, see what happens. Usually what I do is just kind of play around with the thing and see what it turns into. Now this one, if I look at all my answers, no sines, cosines, no sines, cosines, there's a sign there, but in general, it doesn't look like I really want to turn this into sines and cosines and go from there. Although maybe. You know what? Maybe that's the best way to go on these multiple choice trig identities. Always. If you can't see another way to go, although in this case I actually can. You know what? I'm not going to do that here because I can see what the answer is. Pretty sure this is the answer, but this could be the answer. Why do I think there is a 1 plus secant x in the numerator? Because what would our typical first step be here? It's going to be A, but I'll show you why here in a second. Conjugate. Whenever you see this, think conjugate.
All right.
Because there's no other trig identity for that. If I multiply it by the conjugate, it turns into 1 minus secant squared, which is equal to what?
Tangent squared.
No, negative tangent squared. But it's still an identity. Correct? In other words, tangent squared plus 1 equals secant squared. So if I bring the secant over to the left and take the tangent over to the right, I get 1 minus secant squared equals negative tangent squared.
Yeah.
So I'm going to multiply this thing by the conjugate with the intent of substituting negative tan squared for the denominator when I get it. 1 plus secant x over 1 minus secant, 1 plus secant x. That's the number 1. So what do I get in the numerator? I get, and never multiply never distribute this out when you do this technique. Otherwise you'll have to undo it. That gives me 1 minus secant squared there. Now I can substitute negative tan squared for that. Now I can simplify it. And I get 1 plus secant x over negative tan of x. Which answer is it?
A.
Yeah. Now, the one thing we do know is that it's not B. In other words, whenever you've fooled around with it and you come up with something that is clearly the negative of that, even though everything else looks exactly right, and one would be tempted to pick that based on that. In other words, if you're taking the test, you might get to this point and say, wow, I must have made a mistake. I got the wrong sign. I'll go with B. Well, that would be a mistake. In fact, the only thing you've proved is that it's not B. And you can categorically say it isn't B. Now, how do you turn it into A? Well, tan x in the denominator is the same as cotan x in the numerator. The negative stays with it. We still have the 1 plus secant x. Three. We have to find all solutions in the unit circle. It's the first step.
Factor out of sine squared x.
Plus what?
1.
Now what?
Put 2 sine x plus 1 equal to 0.
So sine x would equal minus 1/2. Where does that occur?
That occurs at...
Start with the first. I always start with the first, even though that's not going to be an answer, but it's nice to know what that first angle is.
30 degrees?
Pi over 6. Let's work in radians.
Okay.
So what's the quadrants that we're supposed to be in?
If sine's negative, third and fourth.
Okay, what's the third quadrant answer for pi over 6?
210 degrees, so in radians it'd be... Can you go over how to convert again?
Yeah, well, let me first of all show you my technique for doing it. And then I'll give you the mathematical technique. If I draw my unit circle, this one is 180 minus theta. Well, I could write that pi minus theta. And this one's theta minus, excuse me, this one is 180 plus theta. Nah. Theta minus 180, or theta minus pi. So if I want to find my third quadrant angle that is equal to pi over 6, well, I just add pi to both sides. Pi plus pi over 6 is 7 pi over 6. If you want to do it by converting degrees, well, then multiply by pi over 180. And that also gives you 7 pi over 6, but not quite as easily. In other words, you get 210 pi over 180, and you have to simplify that down to 7 over 6, which isn't always that automatic to do. But this is the algebraic way to convert degrees to radians. Just always multiply it by pi over 180. But I think it's actually easier to know both of these. And in the fourth quadrant, it's 2 pi minus theta. So what is the fourth quadrant? If the formula for fourth quadrant is 2 pi minus theta, what's the angle in the fourth quadrant? In other words, 2 pi minus theta has to equal pi over 6. So solve for theta.
Is it...
What's 2 pi minus pi over 6?
Is it 5 pi over 4?
It's 11 pi over 6. Think about 2 pi minus a pi over 6. Well, we got to find a common denominator, which is 6, so that's 12 pi over 6. 12 pi over 6 minus 1 pi over 6 is 11 pi over 6.
Okay, yeah, alright, that makes sense now.
And that's the angle that agrees with 330. In other words, that's 1 pi over 6 short of being 360. And that's another way to get it. It's just 2 pi minus a pi over 6. But you could also convert it to 330 degrees and then multiply that by pi over 180 to come up with 11 pi over 6. So our two answers based on this are 7 pi over 6 and 11 pi over 6. Is that our answers, or is there one more?
I think that's it, isn't it?
Well, how about that can be 0?
Oh, that's right. So sine squared x equals 0.
Meaning x is what?
Sine inverse.
Where is the sine equal to 0 in the unit circle?
0. Oh, in the unit circle? Yeah.
Just 0. In other words, if I graph the sine function, excuse me, what am I thinking? It's equal to 0 there and there. So 0 and pi. So our answers, it's been a long day, sorry. You're like my fifth.
C.
You're like my sixth student today. And there's a seventh somewhere that thought he was supposed to have an appointment at 8:30. Okay, so there's our 4 answers right there.
So it's C.
Yes. Ooh, did I miss one? Oh, no, it's C. Yeah, sorry. Oh, I'm really out of it. Okay. I didn't even see that pie sticking in the middle there. All right. Simplify. Well, simplify is a little different than verifying. Simplifying is, first of all, I know that the result is going to be simpler than what I start with. Not sure that helps me a whole lot with this problem because I can't really tell if that's simplified relative to that or not. Is C the right answer? Factor a tangent out of C. What do you get left over?
You get tangent x and then cosecant x plus cotangent.
In the numerator.
Yeah.
Well, here it's in that, only it's in the denominator. So it's not C. In other words, sometimes you can prove that that is not equal to that quite easily. Okay? So it could be A, B, or D. I'm inclined to try to make it be D. And the reason is I can turn this into sine, cosine, I can turn that into sine, I can turn that into cosine, sine. Meaning my answer probably has a sine or a cosine in it. That's D, not A. But let's see. Maybe I'm wrong. So first of all, we have sine over cosine divided by 1 over sine plus cosine over sine. Well, that's helpful because got a common denominator. So let's add the denominator, flip, and multiply. So I'm going to multiply this by sine squared over 1 plus cosine. That doesn't look very promising. Sine cubed. Now, how do I know D is not the right answer? Because this thing is equal to sine cubed over cosine times 1 plus cosine. So if D were the right answer, nah, I guess I can't say that. Nah, I don't know. Hold on. See, if I multiply the bottom by the conjugate, no, that's not going to help. I'm going to have 1 minus cosine in the top. I will be able to cancel out the sines, but I won't be able to do anything with that 1 minus cosine in the top. So this doesn't look promising either. So it's either one of these two here. Well, I don't know. It could still be that. But that doesn't look like the right direction to go to me. The bottom. What was the bottom? The bottom again was 1 plus cosine over sine, right? That's what cosecant plus cotangent is? Yeah, okay. I don't know how I got sine cubed before. It's not sine cubed. In other words, if I replace this with sine over cosine, and now flip the bottom and multiply, I get sine squared over 1 plus cosine. No, I get sine squared over 1 plus cosine times cosine. Sine over cosine times. That still isn't taking me anywhere. Well, let's see. I could replace the sine squared with 1 minus cosine squared, which factors into 1 minus cosine times 1 plus cosine. Now that cancels with that, and I got 1 minus cosine over cosine. Well, guess what that is? I'll split that into two fractions. I get 1 over cosine minus 1, which is secant x minus 1a. Wow. That was a toughie. That was a toughie. I didn't almost see it. And the trick was to take the sine squared that I had and replace it with 1 minus cosine squared and then factor that as difference of squares. Now, there's always more than one way to do these, and there may be a more direct way to get to this, but I don't know what it might be. Let's go on to the next. All right. Is this the last one?
Yeah, on this page it is.
Okay.
But we probably won't have time to get to the next one.
What does it look like we would want to do here?
Common denominator. That's...
Yes, common denominator. I think. What do we end up with as a common... After we multiply those two together, we get secant squared minus 1. Is that an identity for anything?
Yes.
Yes, it is. Tangent. So that's probably the way to go. Even though I don't see any tangents in the denominator, I see a cotangent in the numerator. Right now, I'm guessing 2b is the answer. But let's see if it is. Okay, so that's our new denominator. What goes here and what goes here?
So it would be secant x minus 1, and then secant x plus 1?
Uh-huh. Okay, get rid of all this so I can see what I'm doing. And then I can replace this with tangent squared. And we got secant x plus secant x, so we got 2 secant x minus 1 plus 1 cancels out. We get 2 secant x over tangent squared, or 2 secant x cotangent squared x. Hold on, we're not done yet. I still think it's B. Secant x is, let's see, cotangent x is cosine squared over sine squared times 2 times, what else is going to be in the bottom? Cosine. Secant x is 1 over cosine x. Now I can cancel that with that, D. Okay, so all of these, your first inclination is the correct one. Let me open the next page, see if we got any interesting ones. I'm sure they don't get easier. Well, maybe they do. What are we going to do with that one? Number 6. What do you do when you see a pi over 2 minus x?
That's the, is it reciprocal?
No, that's the cofunction rule. What's the cofunction of cosine?
Sine.
So that's equal to sine x. Like that. Okay?
So it would be C because...
Yeah, secant is 1 over cosine. Now we got sine over cosine, which is tangent. All right, this looks tricky. No, not really. I thought it was at first. First step?
Factor.
Yeah. If you can't turn them all into the same trig function, then factoring is almost always the case. Because I can factor out a cosine x, leaving behind, and now I can use the zero product rule to solve it. In other words, I got one thing times another thing equals 0. Now I can say cosine of x equals 0. Where does that occur?
That occurs at 1. So pi over 2 and 3 pi over 2.
In other words, it's where the cosine curve crosses through the x-axis. And it does it in 2 places. And the rest of it is sine x equals negative 1/2. We just went through that. What were those two?
Pi over 6, 7 pi over 6, 11 pi over 6.
Just the 7 pi over 6 and the 11 pi.
Yeah.
In other words, the pi over 6 was the first quadrant angle. And that's just a basis to start from. Make sure you don't include that as your answer, because that would lead you astray. So what do we got? It looks like B. This one is kind of peculiar. No. I'm always multiplying this by 1 minus sine. You see why? Why that's such an obvious step?
Yeah.
I'm going to end up with, in the denominator, 1 minus sine squared, which I can replace with a cosine squared, which I can cancel with that cosine. So I end up with cosine times 1 minus sine all over 1 minus sine squared, which is cosine squared. Now, I canceled that with that, and I got 1 minus sine over cosine, which isn't one of the possibilities, but notice I can split that into 2 fractions. What are they?
1 over cosine and negative sine over cosine, so secant and cotangent, negative tangent?
No, it's tangent. Yeah, negative tangent. So secant minus tangent. Factor and simplify that. What are the factors going to look like?
Secant squared, and then tangent squared.
Minus tangent squared. In other words, we have to produce a middle term of minus 2, that times that, and this does it. And it produces a n term of plus tangent to the fourth. Okay, what is secant squared minus tangent squared equal to?
1.
D.
Yeah.
No, D. In other words, 1 times 1. And it is 1. In other words, start from this. Subtract tan squared from both sides. You get secant squared minus tan squared equals 1. Actually, even if it was negative 1, the answer would be 1, huh?
Yeah.
So even if it was tangent squared minus secant squared times tangent squared minus secant squared, they're both equal to 1. Do this one.
It'd be cosine squared theta equals 1/2.
So cosine of theta equals what?
The cosine theta equals the square plus or minus square root of 1/2.
Thank you. I was sure you were going to forget the plus or minus. That's an amazingly difficult thing for people to remember. I can't tell you how many people don't put it in, even after I say it a million times. So square root of 1/2 is the same as what standard trig function ratio? Square root of 2 over 2. In other words, it's 1 over square root of 2. In fact, let's write it like that. Let's write it as 1 over square root of 2 because it actually makes it a little easier to solve. So what's theta going to be?
1 over root 2 would be 45.
Pi over 4. And since it's plus or minus, we need the 45-degree angle in all 4 quadrants. What is it in the second quadrant?
115.
3 pi over 4. In other words, all I'm going to do is keep adding pi over 2. 5 pi over 4, 7 pi over 4. D. How's that for covering the second page in 5 minutes?
Yeah.
All right, Jackson, good luck on your test.
So I probably won't have any more appointments for like the next week or so because I get knee surgery Friday, so I'll be out of school for about 4 days probably next week.
Okay, you have an arthroscopic surgery?
Yeah, well, in the beginning they scope it, and then I have MPFL reconstruction, and then I have an alignment issue they have to fix, so they have to like cut bone and stuff.
Wow, that's all from football, huh?
Yeah.
Well, I guess better than concussions.
Yeah, oh yeah, definitely.
All right, well, good luck on your knee surgery, and I'll talk to you afterwards.
All right, thank you.
All right, bye-bye.
Bye.